Hello, this is Holden. The equation that I'm going to be using is z is equal to negative x squared plus 2y plus 5y at the point negative 3, negative 2, negative 11. Right, I'm going to be using the gradient of this big F, where big F is equal to little f of xy minus a z, which is also equal to 0. So, right, all that's, I'm going to be taking the gradient of big F. So to do that, I need to take the gradient with respect to, or I need to take the partial with respect to x, y, and z. So f sub x, f sub y, f sub z. I'm going to set these equal to f sub x is equal to negative 2x, f sub y is equal to 4y plus 5, and f sub z is equal to negative 1. Right, just because I have that minus a z term. Then for x and y, given the point negative 3 comma negative 2, right, plug in those x and y values to get what my output is for the partial derivative. So partial with respect to x is going to equal 6. Partial with respect to y is going to equal negative 3. So my gradient of big F is equal to the vector 6 comma negative 3 comma negative 1. Right, that's equal to grad F. You can see the work I did there, right? There's that stuff with the values and then the vector equal to grad F, gradient of F. So then, to do the normal line, right, I have the gradient is perpendicular to the point, or normal to the point. And to do a normal line, right, it's a line, so you need a point and you need a direction. So the gradient's just going to be my direction. And I'm given the starting point, negative 3, negative 2, negative 11. So, right, entering all that into a parametric equation, right, I'll do x sub t, y sub t, and z sub t. And what I end up with is x sub t is equal to 6x minus 3. Y sub t is equal to negative 3, x sub t is equal to 6t minus 3. Y sub t is equal to negative 3t minus 2. And z sub t is equal to negative t minus 11. So, right, I get those three for my values. And then to do the tangent plane, right, it's the same thing where, well, for the tangent plane, what you need is a normal vector and a point. And I have a normal vector to the point, right? That is the gradient. So if I use the gradient, perpendicular to the gradient is going to be tangent to the point. So if I do a plane where I use the gradient as my normal vector, I know that plane is going to be tangent to my point there. So I'm just going to do this plane. So then, right, it's going to be I'll do the plane in the form, right, 0 is equal to the dot product between the normal vector and x minus x naught, y minus y naught, z minus z naught. So in this, that's going to mean that 0 is equal to 6, negative 3, negative 1, dotted with x minus negative 3, comma, y minus negative 2, comma, z minus negative 11. Yep. So, solving that. Let me show you my work there. So, solving that, what you need to do is you then, do the dot product. So you get 6x plus 18 plus, or rather, minus 3y minus 6 minus z minus 11. If I wanted to rewrite that so that it's z equal to something, say z is equal to 6x minus 3y plus 1. Right? Yeah. And so I have this all written out in a CalcPlot 3D. You're going to need to bear with me just a little bit. Simply because, well, now let me show it. It won't be perfect, but it's going to be what it is. So, right, I have all the lighting I have in here possible. Right, so this is going to be how I show my calc plot. So here I have my calc plot. Right, this big function is right. The big function is equal to my function negative x squared plus 2y squared plus 5y is equal to z. All right, so I have that. I have the point negative 3, negative 2, negative 11. Right, it's on the graph right there, as you can see. Eek. Then, for my tangent line, I have this, right, or normal line rather, and that looks pretty normal to me. And then for my tangent plane, I have that, which also looks pretty tangent to me. So, right, there you have it. Oy, that hurt. I entered the same equations that I did for my work on the whiteboard, and it all worked out in the end. So, yeah, hope you guys enjoyed. Stay subscribed. Stay tuned for any new math videos. And yeah, stay ballin' for life. Thank you very much.